Determine the length of the chord of the given circle. Let us begin. So here we have a circle with a center C, and its equation is given to us: x squared plus y squared equals to 9. And we have a chord whose equation is also given to us. The equation of the chord is x minus y plus 2 equals to 0. We are required here to obtain the length of this particular chord. Let us begin. So there are two ways of solving the problem. So the first way will be, what we'll do, we'll solve the two equations, the equation of the line, the equation of the circle, to obtain the coordinates of the endpoints of the chord. To do that, we will rewrite the equation of the chord, which is the equation of a line, in terms of y, and substitute it into the equation of the circle. So here we are given the equation of the chord, which is the equation of a line actually, x minus y plus 2 equals to 0. So what we can do, we can isolate y here. So y will be equals to x plus 2. So let this be equation number 1. And then we have the equation of the circle, which is x squared plus y squared equals to 9. So what we'll do, we'll substitute equation 1 in equation 2. So equation 2 will now become x squared plus, now in place of y, we'll be substituting it with x plus 2 whole squared equals to 9. So we have used equation number 1 here. Now when we simplify this, we're going to get an equation 2 times x squared plus 4x minus 5 equals to 0. Now this is a quadratic equation. We can use the standard formula to obtain the values of x that I am leaving as an exercise for you to try. So this will come out to be negative 2 plus or minus square root of 14 divided by 2. Now that we have the values of x, we can find out its corresponding y value. So when x value is negative 2 plus square root of 14 over 2, then our y value will be, all we have to do is use equation 1, substitute the value of x with negative 2 plus square root of 14 over 2. That's going to give us y equals to positive 2 plus square root of 14 over 2. And then we have the other values of x. When x comes out to be negative 2 minus square root of 14 over 2, then the corresponding y value, that's going to be equals to 2 minus square root of 14 over 2, which means that we have obtained the coordinates of the endpoint of the chord, which meets the circle at point A and point B. So A has the coordinates negative 2 plus square root of 14 over 2, and the y coordinates is positive 2 plus square root of 14 over 2. And then we have point B, whose x coordinate is negative 2 minus square root of 14 over 2, comma, positive 2 minus square root of 14 over 2. What we can do, we can use the distance formula to easily obtain the length of the chord. So let's do that. So here we have, let's call we have chord AB. So that will be equals to, we'll take the square root. Underneath the square root, we need the difference of the x coordinate. So this will be the difference of the x coordinate, negative 2 plus square root of 14 over 2 minus negative 2 minus square root of 14 over 2. We're going to square this result. Add it to the difference of the y coordinate. So that's going to be 2 plus square root of 14 over 2 minus 2 minus square root of 14 over 2, and then square this result as well. When we solve this, we're going to get the value 2 times square root of 7. So this is going to be the length of the chord. The length of the chord whose equation is given to us, x minus y plus 2 equals to 0. Now we'll go to another method, that is the standard formula method. We have already derived this in the first lecture. We'll be using the standard formula to obtain the length of the chord. So let's do that. Now the standard formula is, if we want to find out the length of the chord, then it is given by 2 times the square root of square of the radius minus c squared. Now c is the y-intercept of the line or the chord, divided by 1 plus m squared, where m will be the slope of that particular chord. Okay, so our goal will be to determine the radius, the y of the circle, the y-intercept, and the slope of the line. So we'll start with the circle. So here clearly the radius is going to be equals to 3 units. And this equation, we will convert it into the slope-intercept form. All you have to do is rewrite the equation in terms of y equals to mx plus c. So here we have y equals to 1 times x plus 2. We are only rewriting in the form y equals to mx plus c, where m is the slope of the line and c is going to be the y-intercept of the line. So here we have m value corresponding to positive 1 and the c value will be equals to 2. So let's substitute these values here. We have 2 times the square root of the radius squared, so 3 squared minus c squared, that's 2 squared divided by 1 plus the slope. So slope is 1 here. We get 1 squared, which is 1. Further simplification gives us 2 times the square root of 3 squared, that's 9, minus 2 squared will be 4 divided by 2. So 4 divided by 2, that's 2. We get 2 times the square root of 7. So we have obtained exactly the same value. But this is a quicker method. Only thing that we'll have to remember this particular formula.